Oh, I have to take this off. Okay, today, guys, we're going to do mostly around percent. So it'll be the last half of the lesson, which we'll make sure we get to, since we have the full time for you guys today. But before we get there, we want to just cover a few of these definitions. That we've talked a little bit about them, but not necessarily giving you the mathematical definitions, so we want to make sure you had them. The first one is a formula. A formula is a very useful mathematical tool. It is an equation that shows a relationship between certain quantities. In math, we have many different formulas that we use on a consistent basis. Basically what's happened is mathematicians a lot smarter than me have figured out certain relationships that always happen. And they put them into formulas. So some famous ones are here, the Pythagorean theorem, where you can find the length of any right triangle, all the different sides. Stuff like the area formulas, volume formulas. Basically for every shape, they've made it very easy for you to determine what the outcome is because they're consistent. And what they do is they use, most of the time, variables inside of the formulas. The variable we've talked about a lot, but just to make sure you have the mathematical definition, is a symbol, usually a letter, that is used to represent a number. So in other words, it's basically a placeholder saying, I know there's a number that goes here, you just tell me what number you want to go put in there, and then we can give you the answer for it. Now, we've talked about this a couple times as well. What are the most common variables that we use? 7?
X and Y.
X and Y. Why do we use those two variables so often? 7?
Because they're the letters that you put on the sides of a grid.
Because that's how we graph. So we use those to graph coordinate pairs and be able to take our algebraic solutions and graph them on graph paper. Okay? So we'll talk about that in just a second. But the other big definition we have is percent. Percent, believe it or not, if you break it down for that, by the pieces, it tells you exactly what it is. The definition is in the word itself. So we've been doing a lot of ratio stuff, right? So if I say it's 18 miles per gallon, what does that per mean? That's telling you it's a ratio. Out of, right? What does cent mean? It doesn't even measure. Like, how many cents are in a dollar?
100.
How many years are in a century?
100.
Guess what cent means?
100.
100. So the word is actually the definition. Percent means out of 100. That is the definition of percent. The symbol for percent actually tells you what it's out of as well. Percent is out of 100. So the number it's out of is right in the symbol that is used. Okay? So that's going to be critically important because we're going to do a lot of stuff with percent. You need to understand percent, by definition, means out of 100. So that's what's going to allow us to do a lot of the work we're about to do as we move on down. Now, I wanted to talk to you guys real quickly about the ways to write multiplication. We added a note last class where we talked about it. We said, if I write a number right beside a letter, that means multiply. Because you're going to see a lot of this. In elementary school, you guys were taught to do this, right? Okay? Here's a problem. What did we just say? One of the most common variables we use in mathematics is X. So now that we're using so many more variables, if I see 2x4, how do I know if you're talking to multiply or if you're throwing a variable in there? I don't. So we really need to kind of get rid of this. I want you guys to stop writing that X as times. Instead, the dot is going to be the more common way to do it. Make sure that the dot is raised in the middle so that it doesn't look like a decimal place. Okay? The other big one, and because we're doing so much with variables, is going to be just writing the letter beside the variable. That means multiply. You're going to see this a lot as we move forward. The other big thing we're going to see is if the second number is in parentheses. I'll be honest, this is going to happen more as we get into order of operations, where you're going to have a parenthetical piece that you're supposed to do all the pieces inside, but when that number is sitting outside of that parentheses, it means you're multiplying by the quantity inside. Okay? So you're going to simplify what's inside, it's going to come down to one number, and then multiply by what's on the outside. Any questions on any of the vocabulary piece of today's notes? Okay?
So what's the 2 parentheses 4? Well, you said simplify to 4?
No, what I'm saying is this was something inside, so it's probably started. So, for example, it was 2 and then 6 minus 2 on the inside. So, order of operations, I have to do the stuff on the inside first. So, 6 minus 2 is 4. So, I would simplify that as 2 times 4. And that's just saying I'm multiplying 2 by the quantity on the inside. Okay? We'll also use distributor property, which would have said that 2 times 6 minus quantity of 2 times 2, or 12 minus 4, which is also 8. Okay? But we'll talk about those pieces later. Okay, the other big one we're going to do today is working with percent and moving it into fractions and decimals, basically back and forth between all 3 of those. So percent to fraction is going to be one of your easier ones because percent, by definition, tells me I can put it in fraction form. So let's take, for example, if I'm going to use 48% and I'm going to try to change it into a fraction. The first thing I do is I write the number portion of the percent. So it's 48%, what's the number portion of it? 48. I just write that, 48. I place a fraction bar with the 100 below it. Why do I put a 100 below it? Because it's percent. Percent by definition is out of 100. Is everybody tracking so far? Okay. Then I simplify my 4 key numbers. Who remembers my 4 key numbers? Got it?
2, 3, 5, and 7.
Excellent. Glad somebody's remembering. So our 4 key numbers are 2, 3, 5, and 7. If you have forgotten those, please write them down again. Keep writing them down until you start to remember them. Because we need to be able to do this. So all I'm saying is, I just check both numbers. I say, can I divide both 48 and 100 by 2?
Yes.
Yes, so I do it. So I divide them both by 2 and I get 24 and 50. Then I check again. The key on this is always check. So can I divide 24 and 50 by 2?
Yes.
Yes, so I do. So I divide them both by 2 and I get 12 and 25. Then I check again. Can I divide them both by 2?
No.
Can I divide 25 by 2 evenly? Can I divide them both by 3?
No.
By 5?
Nope.
By 7?
No.
Really, you should roll through them that fast. If you've said no 4 times, you're in simplest form. It's that easy, guys. Now, if I knew right away I could divide 48 and 100 by 4, you can do it in one step. But you don't have to. Sometimes it's actually easier to divide it by 2 twice than to try to sit and think of all the numbers that could possibly go into it. Because is it hard to divide by 2?
No.
It's really easy. Okay? So a lot of times you actually save time by just doing it. Our next one, and honestly that's all you got to do, percent to fraction, that's it. The next one is where our little symbol here, the D2P comes in. We're going to refer to it as Dr. Pepper. Why? Because Dr. Pepper is the nectar of the gods. It's like the greatest drink ever created. For any of you that may have noticed, you can see a 12-pack sitting on my desk over there. So I do mean this. But Dr. Pepper also helps you remember how do I go from a decimal to a percent. Because percent means what?
Out of 100.
Out of 100. You're going to hear me say this so many times, guys. Get used to it. Because the definition of that percent tells us so many things. This is one of the easiest things you're going to do. So again, let's start with our 48%. Okay? In our 48%, if I'm going percent to decimal, I'm going to move the decimal 2 places to the left. And then I'm going to drop the percentage sign. So that's what this means. It's going decimal to percent. I'm going to move it 2 places. Why? Because it's out of 100. And when I multiply or divide by hundreds, it just means I'm moving my decimal twice. The figure shows you which way to go. So if I'm going percent, the P, to the decimal, which way does the arrow go? Left. So I'm going to move it left. If I don't see my decimal place, where is it?
Right.
Where is it, Rowan? John? Where it exists. Where is it supposed to be? Right, so where is it? I don't have a decimal place. Avoid eye contact at all costs. Because then you might get caught on, right, Keith? You don't know where the decimal is? To the very right. If I don't see it, it's on the very right, okay? So now, since I need to move it, I have to know where it is. So I put it in on the very right. Where am I moving it? 2 to the left. I move it 1, 2, guess what? You just showed all of the work. And then I drop the decimal point, the percent sign. So the answer would be 4800. Okay? Now, if I'm going to change decimal to percent, now I'm going to go the other way. So you can see D to P, the other arrow goes to the right. Meaning, if I have a decimal, let's say 6/10, I'm now going to move it 2 to the right. So I move 2, 1, 2. What goes in an empty bucket? A 0. And then I add the percent sign. So I can rewrite that as 60%. So 6/10 is 60%. Pretty easy, right? Guys, literally all you gotta do, you move your decimal. 2 to the left if I'm going decimal to percent. 2 to the right if I'm going percent to decimal. The last thing we do is fraction to decimal. So for example, I'm going to give you a fraction such as 4/5. To change it to a decimal, all I need to do is divide the numerator by the denominator. Again, one of the hard parts on that is always remembering who goes where. So that's where the second part comes in. The top guy is the winner, so he goes in the house. The loser is outside in the rain. So the winner goes in the house, the loser's out in the rain. Now we just do the division. Will 5 go into 4? Nope, so I add a decimal and a 0. My decimal comes straight up in my answer. 5 goes into 40. 8 times. There we go, 8/10. 4/5 equals 8/10 as a decimal. Any questions? So you've just seen all 3 of the things that we really need to focus today. Percent to fraction, percent to decimal, and fraction to decimal. Very important since this is on your test for next week. Next week.
Is it a module or is it a mid-module test?
The end of module. No, we did a mid-module test. That's why we're doing the end of module test next. Okay, go ahead and open your books, page 98.
What thing are we going to do after that?
After that, we'll do the mid-module 2 test.
The mid-module 3?
No, then end of module 2.
How many modules are there?
Page 98. 6. We have 6 modules this year. Okay, on this one, on a Saturday morning, you can cut 3 lawns in 5 hours. Your friend can cut 5 lawns in 8 hours. Who is cutting lawns at a faster rate? So they already set up the proportion for us on this first one. How do I go from 5 to 1? So guess what I'm going to do to the 3? Yeah, but one person is just a little bit slower. We're trying to figure out who. So how do I divide 3 by 5, guys?
3 in the box, 5 on the outside.
3 in the box, 5 on the outside. Well, going to 3, I do my decimal. It's going to go 6 times. 30 gets me a 0, so it is 6/10 lawns in an hour. Yes, sir. Page 98. On the other one, my friend does 5 lawns in 8 hours. How do I go from 8 to 1? Divide by 8. So I'm going to take 5, divide it by 8. Doesn't go to 5, so I do 50. That's going to go 6 times. 48 gives me a 2, still not at 0, so I'm going to bring down another 0. Goes into 20 twice. Subtract 16, still not at 0, so I'm going to bring down another 0. It's going to go 5 times. Subtract 40, and now I'm finally at my 0. So what does he do? he does 625 thousandths of a lawn in an hour. Have we answered the question?
No.
So what's the answer, Debbie?
You are faster than your friend at mowing lawns.
Excellent. Everybody agree with Devin? Anybody disagree? Then why are you all wrong? That's not what you said initially. You said you supported Devin. Yeah, I asked you who didn't agree and you didn't raise your hand.
Oh, wait. Oh, I got them cooked up. Never mind.
You understand?
I
Does
got
everybody see it? So, I like what Ms. McShann did earlier. You want to say that again?
You can think of it like money. That's in the tenths place, the 0.6, so that's 60 cents because it's 6 tenths. Or you have 62 cents with a 5 after to round. So which one is more, 60 cents or 62 cents? So he does more.
Okay.
You can also add 2 zeros to where they have the same number behind the decimal, and you'll have 600 and 625. And that would be easy to see as well.
Those that didn't hear that, she said basically you could add the 2 zeros so I have the same decimal places. Which is bigger, 625 or 600? Make sense? Okay, any questions on that page? Okay, turn the page. And we have a fun one for you. Uh-oh.
It's on the same page for us.
Hopefully that's still going. Okay, good. Looks like it's still going. We didn't lose our recording. Try again. It's on the same page. Oh, that's it. It's on the bottom. So, but they didn't tell you what it was. So here's the word problem for you. You're at a restaurant. You're under advertising. You hire 2 students to deliver menus around town. Dara delivers 350 menus in 2 hours. And Drew delivers 510 menus in 3 hours. You promise a $10 bonus to the fastest worker. Who gets the bonus? So I'm going to give you guys 2 minutes so you can figure it out on your own. Do what? Change your mind? Donna, she has 350 menus in 2 hours. How do I go from 2 to 1? Divided by 2 gives me 175. We've got Drew, who does 510 menus in 3 hours. How do I go from 3 to 1? Divided by 3 gives me 170 menus.
I'm off today, sorry.
So who gets the bonus? Darla gets the bonus. We all have our off times. Even Miss McShann. I forgot I was back up here. Let's take that up. Okay, any questions on that one? Pretty easy, right? Okay, we're going to go ahead and skip this one. Go to this one. It's a little more difficult. This is the next page. So, 99. Same deal. We're going to give you guys about 2 minutes to do this one, and then we'll go over. Okay, so consensus is the secretary types faster. So let's work this out. She's secretary is 225 in 3 minutes. The computer teacher is 105 words in 90 seconds. Can we still compare them with different units? Can we?
Yeah.
Yes. Who types at a faster rate? You guys are saying secretary. So we write this down, and here is a perfect example of why it's so important on these problems to make sure you write down the units you're comparing, right? So I write this down and I go words and minutes. I want to get it down to a per minute rate. How do I go from 3 to 1? Divide by 3. So I divide 225 by 3 and I get 75. Do what? 216. So that's 25. And the other one, the computer teacher does 105 words in 90 seconds. So I write it down and I say words in seconds. But who saw the issue right away? What is he comparing here?
Minutes.
So what do I need to do here?
You need to change it. Yeah, you need to 1.5.
Change it to minutes, right? So I can change that. How many minutes are in 90 seconds? 1.5.
Multiply by 2.
Okay? And then minutes here. Multiply by 2.
Yeah,
Actually, I kind of like that idea. If I multiply by 2, what do I get?
3 minutes.
210 words in 3 minutes. Now I have a comparison that I can use. 225 or 210.
That's exactly what we did.
Right? Okay? It also would be divide that down. You guys know how to divide by decimal?
A little, but it's hard.
Okay? It's really not.
It's hard.
It's 105 divided by 1.5, or 1 5/10. What's the first thing I need to do? Can I have a decimal in my outside divisor?
Oh no, I remember. You just moved the decimal.
I just move the decimal. So every time I move the decimal here, I move the decimal here. Now that the buckets get a 0.
Yeah, I remember that.
So now 15 won't go to 10, it goes into 105 7 times. Gives you a 0, so that is 70. So you could have found it as 70 words per minute, or actually, like what Devin did, just double that, and then I'd have 3 minutes for both.
It's a lot quicker.
It's a lot quicker to just double them. Okay, so look for those patterns. If you did that on a test, and I was expecting you to go to a certain rate, I would probably give you credit, because that is a rate. It didn't have to say unit rate. That would be the only real big thing to worry about. If it specifically said unit rate, then I would have to break it down to ones. Yes, so.
My brother was way simpler to do that. I just instantly realized that 10 minutes is,
Yeah.
words per minute. Wait, can you pull up? Because I can't see the entire question. Thank you. So, 225 words in 3 minutes and 105 words in. Actually, never mind. I think that's mine.
I have no idea where you're going with all that, but 90 seconds is half of it. So you cut that in half, which isn't as easy, or you just double this, which has been very much easier.
Yeah, that's pretty much what it is.
Okay, good. Let's go ahead and turn real quickly on your homework. Homework, it's talking about faster rate. So you've got several different options. The easy way is go ahead and break them down to unit rates or find a common comparison. Okay? So, for example, here's a 10 seconds and a 5 seconds. That should be pretty easy to do, right? Devin just showed you a great way to do that. 60 feet, 10 seconds, 42 feet, 6 seconds. No easy way to do a comparison, so break those down to a unit rate. But 6 of them, show your work, guys. Make sure you are showing your work. I cannot stress that enough. So if you're doing where you're just doubling that, show me it in your math. 6 questions, that one shouldn't take you very long. Okay, then open up to lesson 24. Should be page 101. The next piece we're going to do is starting talking about percent and rates per 100. So a fruit farm consists of 100 acres on which 3 different types of apple grow. On 25 acres, the farm grows Empire apples. Macintosh apples grow on 30% of the farm. The remainder of the farm grows Fuji apples. Shade in the grid below to represent the portion of farm each type of apple occupies. Use a different color for each type of apple. Okay. Create a key to identify which color represents each type. So we've got several different pieces here. Now, if you guys have markers, you can do that, or we can just use different shadings. Okay, the first one, we've got 25 acres. So how do I do 25 acres, guys? Shade in 25 squares, okay? So, in that case, it's going to be 2.5 rows. So I'm just going to shade in 2.5 rows. Okay? It also said that I needed to do a key, right? So my key is going to look like that. Whatever you use, if you're using a color, put the color. If you're using a symbol, you can just use the symbol. And then what are we supposed to do? A part to whole ratio. So what is our part to whole ratio on this? Sorry? 25. Well, on the first one. Right? Did I mess it up? No? 25 acres is empire. Man, you made me worry about it for a second. 25 to 100. Is that my final answer? What do I do, Sean? Simplify, always, right? So I divide them up by 25, and it gives me a 1-to-4 ratio. Then I do my next one. It's 30%. So how do I show 30%? 3 rows. So 3 rows, and obviously it doesn't matter if you go up, down, sideways. Just make sure you have 30 boxes that are colored in or marked in some way to show that it is the Empire apples. So here we have 35. Again, don't forget your key. Whatever you ended up using, make sure you show it. Am I way faster than you guys are on the coloring? You guys are doing okay? So what is our part to whole ratio for the Macintosh apples? 30 to 100. And divide both those by 10. Gives me a 3 to 10. If you did 2, that's awesome. Then you'd be able to do 5. You can do it in 2 steps, or you just recognize they both end in a 0. I know you divide them by 10. Okay, and then our last set of apples, they said, is the remainder. So all I got to do now is color in the rest of the boxes. Do you want to take your little sticky pad?
I'm good. Yes, I do. Lots of people that do this.
Okay, so all we do is color it in. Okay, and then our final piece on that one is how many boxes were left for me to color in? 45. 4 holes and then half of one. So that's 45. What can I divide both 45 and 100 by? 5 gives me 9 to 20. Any questions on any of those? Yes. Katie.
I either shaded it wrong or I just
25, 30, and 45. 25 and 30 is 55. You get to 100, there's only 45 left. So everybody's doing okay on that one? Okay, so now we're going to look at this next question. The shaded portion of the grid below represents the portion of a granola bar remaining. what percent does each block of granola bar represent? So what percent does each of those blocks represent?
No, they each were
The whole thing is 100.
1%.
1%. So each is 1%. Is everybody okay with that? What percent of the granola bar remains? 7?
20%.
Excellent. Everybody see that?
It's the portion that is. We said excellent, so it's about percent.
Everybody agree with that? Who said no?
Oh, wait.
Devin gave us the answer.
Oh, crap. The shaded portion represents...
Oh, you mean it's important to read what it says?
I just always read what it says.
Always read what it says. The shaded portion is what's remaining, right? So the shaded portion remains. So how much was that? 80%. Guys, I'm more than willing to write the wrong answer up here to make sure that you understand what you're supposed to be doing. Okay? What other ways can I represent this percent? So how can I take 80%? What else can I represent that as? I gave you a hint. Look at your notes. 80% I could also do as a fraction. So how do I do that? I write down that number, 80%, means out of 100. I simplify it, I divide 80 and 100 by. 2. Okay, 2 gives me 40 over 50. What can I divide those by? 10. Oh, that's our lunch. So we'll finish this up when you get back from lunch, guys. Because this one's where it gets really fun. Ready to turn the page, guys?
Whoa.
So, for each figure shown, we're going to represent the gray shorted portion as a percent of the whole figure. Write your answer as a decimal, fraction, and percent. So we have 3 different things that we need to do. So our first one, and what we're going to do is we're going to go, the dark gray shaded, okay? So what percent is that dark gray for the first figure?
20%.
20%. Okay, so we're going to start with percent, because these are all out of 100, so that should make it easier. So then we'll go percent to decimal, because that's the easy one to do. So if it's 20%, how do I turn that to a decimal? Devin?
Move the decimal point 2 places to the left.
Excellent. I don't see it. It means it's at the end of the 0, so that becomes 0.2. If you add 0.20, I'm okay with that, but technically I don't need that 0 anymore. So you can write that one in either way would be acceptable. And then as a fraction, again, to do a fraction, I literally just write the number 20, put my fraction bar over 100. Why did I do it out of 100? Because that's what percent means. 20 and 100, what can I divide them both by? 5. So divided by 5 gets me 4 and 20. What can I divide both those by? 4. Divide them by 4 gets me 1 and 5. So if you saw I could divide them both by 20 at the first step, you can do it. But again, 2, 3, 5, 7 will get you there. That's the important piece on that. Solo?
You can print this out because it's a PDF.
Yeah, fine. He just made an acrobat joke, Adobe. Okay, so our second one, again, we're going to focus on the dark gray. So the dark gray is what percent? Lily? No?
25.
It's 5 by 5.
Okay, 25.
Okay, so that's 25%. As a decimal, again, all I do is I move it twice. So that becomes 25 hundredths. Then as a fraction, I literally just write the number down. 25 over 100, what can I divide both those by?
25.
Sean? 25? If you all see the 25, you can do the 5s and you'll get there. But 25 gets us there in one step. I've been underlining all my answers, sorry. And picture C, this one might take you a minute to count the gray boxes.
Wait, but I thought we were counting the dark first.
They don't have the super dark, so we're just going to do the gray. Question? Do you have legs?
That means we don't have one. You said yes. You just messed up your own words.
May.
May I please put it on?
Sure, go sign out. Who has the count for me on the last one? That's all I get. Anybody else have a different number? Lonnie? 48. Anybody else have a different number? Sean? 58? Interesting. 48, guys. So, 48%. How do I turn it to a decimal? Same as all the rest. I just move it twice. So that becomes 48 hundredths. So there's one answer. There's two answers. Third one, 48 over 100. What can I divide both those by?
8. No.
Can't divide 100 by 8.
8 by
Can't divide 48 by 5.
8 by 100.
Again, start it. If you don't see a number right away, start at the bottom. Can I divide by 2? Yes, that gives me 24 and 50. Then I can say again, divide by 2 gets me 12 and 25. Ironically, that was the one off your notes. And I literally just made 48 off the top of my head. So I haven't done that problem yet today. You guys feel okay on these? Okay? So a ratio is being modeled in each picture. So basically we're going to get back to what we used to do. Which one of these would be the easiest for you to do the ratio from? The percent, the decimal, or the fraction? The fraction would actually be the easiest. So for picture A, what would my ratio be? John? 1 to 5? I'm going to use a simplified form. So, Caden, I could have started at the 20 to 100, you are correct. But then we still would have to simplify, it would have come down to 1 to 5. Okay? For picture B, the ratio would be, Moani? Good, 1 to 4. And for picture C, it would be, Lily? Good job, 12 to 25. Is everybody okay with all those answers? Yep. Is there any one of those that you might think is not correct? Good, they're all right. How are the ratios and percentages related? Solo? No? 7?
They both have one number being compared to a higher number.
Okay. But what could you say about these ratios versus the percentages?
Oh, they're what?
They're equivalent. Okay? They are, and I'm going to say each equivalent, not all equivalent, because they're not all equivalent, but they're each equivalent to their ratio. Each equivalent. Now this is a really fun. I have not touched a thing, and I'm on my third color. They are each equivalent to the percentage. So if I take that percentage and simplify as a fraction, I get the ratio. Make sense? Any questions on that page, guys? Okay, we're going to go to our next one then. We're going to give you guys a chance to work on this one by yourselves a little bit. But before we get started, I'm going to give you an example to make sure you all understand what's supposed to be in each box. So each relationship below comprises the shaded portion of the entire figure to the whole. Complete the table. So our percentage is 6%. Turn that to a decimal, what do I do? Move it to the left how many times? twice. So I move it twice. 1, 2, empty buckets get a 0. So as a decimal, that is 6/100. As a fraction, again, I just write the number over 100. Then I simplify. 6 and 100 both can be divided by 2. That gives me 3 to 50. The ratio, should I leave it at that? No, I should do what? Simplify. Divide 2 gives me 3 to 50. And then as a model, what does our model look like?
So, what if we did a 10 by 10, or just like a 10 square, and then paint it in 6 of those blocks?
Okay. Actually, I kind of like that one, but I'm going to do the 6%, which would be 6 out of 100. So that one is actually probably going to take the whole big one. Technically, I could do the 3 out of 50. So if I just do 50, I'd be okay. 1, 2, 3, 4, 5. Then 10 across. 5, 6, 7, 8, 9, 10. And I color in 3 of them. Does that make sense, everybody? So that's my model of 3 of 50. So we're going to give you guys, what time do we get done?
15 minutes.
15 minutes. We'll give you about 8 minutes to do as many of the rest of these as you can. And then I'll come back in and give you guys the answers. Okay, guys, I'm not sure how far everybody made it, but I'm going to just throw the answers up really quickly for you here to let you see partially how easy this stuff is. So 60%, changing it to a decimal. Move it twice, 6/10. Turning it into a fraction, 60 over 100. I can divide both those by 20, gives me 3 over 5. I can do the ratio, 60 to 100, which simplifies to 3 to 5. So here's a question I answered on my side. Why do we always simplify? Do I want to draw 100 boxes or do I want to draw 5? I want to draw 5. So really one of the biggest reasons we simplify is to make the modeling easier. Because now I can do 5 boxes and color in 3 of them. There's our model. 600%. This one was designed to get somewhat tricky. We'll see how many managed to get it. So turning it into a number, 6.0 or just 6 would have been acceptable. As a fraction, 600 divided by 100. I can divide both those by 100. Gives me 6 over 1 or 6. Doing it as a model, a ratio, 600 to 100. Dividing them by 100 gets me 6 to 1. And we do keep both of them for the ratio, because the ratio is a comparison of 2 numbers, so we're not going to simplify that one away. But then our model, and this is probably the trickier one, my model is just 6 boxes.
I do a bunch of boxes and can fill these 6 stuff.
That's it. Well, that made a piece of it then. This is actually 6 holes. Okay, 32%. Excuse me. Move it twice. As a decimal, that is now 32 hundredths. As a fraction, 32 and 100, I can divide them both by 4. Gives me 8 and 25. If you took 2 steps to do that, it's not an issue. As a ratio, 32 to 100. And I'll show you just to see it divided by 2 would have given me 16 to 50. You guys, I'm going to do it again by 2, gave me 8 to 25. So either way, you can either divide it by 4 if you see it, or do 2 twice. Did that 2 twice take very long? No. So you're not really losing much time by doing that. So my ratio, or my model now, I need 25 boxes. How can I do this? Yeah, we'll do it this way. So we'll do 2, 3, 4, 5, 6, 7, 8, 9, 10. And then add 5 more on the bottom. And I'm just coloring in 8 of them. So 8 of 25. Okay, did anybody flip to the next page? Okay, so real quick, the nice thing about this is they now have made you go to different areas. This may be very helpful for your test next week to be able to do this. Hint, hint. So if they gave me a decimal, now I move it to the right twice. So that becomes 55%. Turning it, and what I normally do is I do the percent and fraction and decimal first, because once I have the percent, it's easy to do the fraction. So now I can go 55 over 100, divide both those by 5, gives me 11 over 20. So my ratio, 55 to 100, I can divide those by 5, gets me 11 to 20. My model, 20 boxes. And I'm drawing in 11 of them. So the whole first row plus 1 in the second. Okay? Now if they give me the fraction first, that's where we got to do the division. So remember, the top guy goes in the house. So 9 divided by 10. The decimal is going to go straight up. 10 is going to go to 99 times. So the decimal is 0.9. Now that I have the decimal, I just move it twice to get my percent. Excuse me, empty buckets get a 0. So that's 90%. And I'm going to rewrite that. There's my answers to 9/10. My ratio, 9 to 10, because I can just use the fraction form to do that. Then my model, I'm just doing 9 to 10 boxes. Okay, we're almost out of time, so I'm going to switch over to the homework. The last one, though, should have been relatively simple. It was 7 out of 10, 70%. Okay, go to the last page, 106. Excuse me. Really big one on this. They gave you 100 and told you to split it between 3. Do I have to do it evenly? No. Mr. Moore is going to do simple numbers like maybe 30, 30, 40, 25, 25, 50. Take your pick, but don't do 33 and a third for each of them. That's ridiculous.
And you have to use all 30, you can't do all one color.
Yes. And you don't necessarily have to color, but at least make a key to show us what you're doing. So whether you do a color or a just shading, show us what you mean in a key on that one. Number 2, basically the same thing. I will tell you, don't repeat Devin's mistake earlier, make sure you read the directions. Because it's an easy one as long as you pay attention to what you're supposed to be doing. Okay? Questions on your homework? Okay, how you guys feeling on this?
Good.